So in this video today, we're going to go over Pythagorean's theorem. So our objectives are to use Pythagorean theorem to solve for missing sides in a right triangle, to determine if three sides in a right triangle produce a Pythagorean triple, and to classify triangles as acute, right, or obtuse using Pythagorean inequalities. So Pythagorean theorem's in a right triangle. So this only applies in a right triangle. The sum of the squares of the lengths of the legs. So we got our legs here. Whoops. Okay, pen, write for me. We got our side A and our side B, right? These are sides. So lengths of legs equal to the square of the length of the hypotenuse. And remember, the hypotenuse is where? Hypotenuse is always opposite the right angle, right? So we will use this theorem to find the missing side lengths in a right triangle and classify triangles. So here's the other thing I want you guys to know, that C, which is the hypotenuse, use, is always the longest side, okay? And so whatever we're going to do, we're always going to reference the longest side as C, okay? Or longest, yeah, we'll just say side, okay? All right, so here it says find the value of x, give your answer in simplest radical form. So we're going to actually give each of these a value. So I'm always going to label C first, again, across from the right angle. So this is going to be C. I'm going to label this one as A and this one as B, okay? So we're going to say A squared. So this is our formula, A squared plus B squared equals C squared, right? So here we go again. So we're going to go 2 squared plus 6 squared equals C squared. That's 4 plus 36 equals C squared. So that's going to be 40 equals C squared. So now to get C, we have to take the square root of both sides. Now, what you should know is that when we're doing this, we're never going to do the plus minus like we were doing before, because side lengths always have to be positive, okay? So that means that C is going to be equal to the square root of 40. So what we're looking for here when we start factoring this is perfect squares that are factors of 40. So let's talk about what are perfect squares. So a perfect square, okay, so that's a number that we square. Okay, so that would be 2 squared. That's 4. So that's our perfect square, 4. And then 3 squared. That's 9. That's our perfect square. And 4 squared is 16, perfect square. Okay, so I'm going to keep doing these so you guys can see some examples of them. And these are the numbers that we're going to see if do they go into the number that's underneath the radical. So in other words, are they the divisor? Okay. So 36, and then we have 7 squared is 49, and 8 squared is 64, and 9 squared is 81, and I think, you guys get the drift now, okay? So what we're looking for here is which of these numbers in circle, which are perfect squares, could be factor into that number 40. So I think everybody can see that 4 goes into 40, right? So we're going to do 4 here, and we're going to do 4 times 10, and then we're going to put both of these back underneath the radical, okay? Because when we multiply that, we get 40, right? So here's the question. What is the square root of 4? Hopefully all of y'all know that that's 2, and we cannot simplify the 10 anymore. Now, yes, 10 can be factored more, 1 times 10 or 2 times 5, but neither one of those are perfect squares. So this is the answer in simplest radical form, okay? Now we're going to skip down here to the U try 1A, okay? So I want you guys to see that this is a right triangle over here, okay? And that we are going to find this value right here. I'm just going to name it Y, okay? So again, we got to figure out what our C is. So this is C, again, Y, because it's across from the right angle. So that's our hypotenuse. I'm going to label our 9 as our A, and then this Y would be like our B, okay? So I'm just going to, or you know what, we could just leave that bottom B. Let's just do that. That might make it less confusing, okay? So we're just going to name this B down here. It's our green B, okay? So here we go again. Not that y'all can read that very well. That's A equals, so this is equal to A, okay? All right, so we're going to do 9 squared plus B squared is equal to 15 squared. So again, A squared plus B squared equals C squared. So this is 81. That's still our B squared, right? And that's going to be 225. So we're going to subtract the 81 from both sides. That's going to give us B squared is equal to 144. So once again, we're going to take the square root of both sides, right? So we know that B is going to be equal to 12. Okay, so I'm just going to put equals 12 right there. So now to find the other side, this side over here, hopefully you see that this is still, wow, that was not a very good line, y'all. So hopefully you guys can see that this too is a right triangle, right? Because the other side of this is right, okay? Because 90 from 180 is 90, okay? So then I want to know, what is this length right here, okay? So the whole length was 25, so can't we go 25 minus 12, and isn't that going to make this length up here 13? Okay, so once again, we should label our C, that's C up there. So now we have our A, our B, our C. So we're going to say this is going to be our B now, okay? So we're going to say 9 squared plus 13 squared is equal to C squared. So that's 81 plus 169, that's equal to C squared. So that's 250 is equal to C squared. So once again, we're going to take the square root of both sides. So let me give myself a little more space here, okay? So we're going to take the square root of both sides, right? So that's going to be C is equal to the square root of 250. So hopefully you can see pretty quickly that 25 is a factor of 250, right? So we're going to do the square root of 25 times the square root of 10. That 10, once again, can't be simplified, but the 25 can. So this is going to be 5 square root of 10. And that's our answer, okay? So for this next one, we're going to, again, label our C and our A and our B. Let me also say this. It doesn't matter which one you label A and B. It does, however, matter which one you label C, and that's always got to be the side that's opposite the right angle. So we're going to do x minus 2 squared plus our 4 squared, and that's going to be equal to our x squared. Now, hopefully you remember that x minus 2 squared is the same as x minus 2 times x minus 2. Now, the method that most of y'all learned at some point was the box method, right? So I want to make these two numbers the top of my box. And over here on the left, I'm going to put an x and a negative 2, okay? So x times x, so let me do this with x times x is x squared, right? Negative 2 times x is going to be negative 2x. X times negative 2 is still negative 2x. And then negative 2 times negative 2 is 4. Okay, hopefully you recall that in this diagonal, these are our like terms, right? So that term, x minus 2 squared, when we simplify this, is going to be x squared minus 4x plus 4. Our x squared, right here, this is going to be minus 4x, and there's our 4, okay? And then we're going to do this term, which is plus 16, right? And that's equal to x squared. So I'm going to show you a little shortcut here. If we have the same exact term on both sides of the equal sign, then that term's going to cancel out, right? So that means I can cross through this x squared there and that x squared there. So that leaves me negative 4x. I'm going to combine these two terms right here. That's going to be plus 20, and that's equal to 0. So we're going to subtract 20 from both sides. That's going to be negative 4x equals negative 20, and then we're going to divide both sides by negative 4. So x is equal to 5, right? So now, there is a way to check this, yes. So we're going to put that 5 right there. And 5 minus 2 is 3, right? So here we go. Let's double check this. So we're going to do our a squared, that's 3 squared, plus our b squared, which is 4 squared. And is that equal to our 5 squared? That's our question. This is 9 plus 16. Is that equal to 25? 25, yep, is equal to 25. So we just checked it, okay? Great way to check your questions. All right, so our next one is this one down here. Sorry, I was about to skip ahead. So our you try 1b, okay? So once again, this is our C, right? So we're going to make this one our A and this one our B. So here we go again. We're going to do our x squared plus 12 squared is equal to x plus 4 squared. So once again, I would use the box over there. So let's go ahead and simplify this. X squared plus 144. And that's equal to, again, our x. Let's just put it below it. How about that? That's not a bad place for to put it, where I just put it, right? I don't know what's going on with my pen, y'all. Okay, there we go. X and 4, and let's create our box again. So x times x, x, let's do this in red. X times x is x squared. 4 times x is 4x. X times 4 is 4x. And 4 times 4 is 16. Notice here again we have our like terms, right? So this is going to end up being x squared plus 8x plus 16. And that's equal to our x squared plus 144. Now, what did I tell y'all you could do if you have the same exact term on both sides of the equal sign? Yep, you can cross it right out, right there. So we're left with 144 is equal to 8x plus 16. So we're going to subtract 16 from both sides. So that's going to give us 128 is equal to 8x. Then we're going to divide both sides by 8. So x is equal to 16. So here again, this 16 would be there, and the 16 would be here. So that means that this up here would be equal to 20, right? So if we did 16 squared plus 12 squared, does that equal 20 squared? That's our question. This is 256 plus 144. Does that equal 400? It does. 400 does equal 400. So once again, we can check it. Okay? All right, the next one says Randy's building a rectangular picture frame. So I'm going to draw a rectangle here. He wants the ratio of the length of the width to the width to be 3 to 1. And the diagonal to be 12 centimeters. So if it's 3 to 1, then I'm going to say, okay, again, length to width. So this would be length and this would be width, right? So my length, I'm going to write length here, would be equal to 3 times x, right? And my width would just be equal to x, right? And then my diagonal, it says, is 12 centimeters. Now, here's the thing. It said it was a rectangle, right? So that means it was a right angle. So once again, let's label our C. There it is. So now we're going to label one of these A. So let's just say this one's A and this one's our B. So we're going to do x squared plus 3x squared equals 12 squared, right? So x squared, now hopefully you remember that this applies to both terms, right? So we're going to square the 3 and the x. So this is going to be plus 9x squared, and that's going to be equal to 144. And remember, there's a 1 there, and these are like terms, right? So aren't we going to add the 1 plus the 9? So this is going to be 10x squared is equal to 144. Divide both sides by 10. So x squared is equal to 14.4. And then once again, take the square root of both sides. So x is equal to 3.8 centimeters. All right, our next one talks about Pythagorean triples. So the key here is that these are 3 non-zero whole numbers. That means no decimals, no fractions, y'all. No radicals, okay? So it says such that a, b, and c such that a squared plus b squared equals c squared. So, and I'm going to remind you again that I said this earlier, that our biggest number is always going to be our c. So that's our c, that's our c, that's our c, and that's our c. And this is going to be relevant more as we move through the lesson, okay? So here's the next one. It says find the missing side length, tell if the side lengths form a Pythagorean triple. So this is going to be our c, right? Now I'm going to again make my 14 my a and 48 my b. So this is going to be 14 squared plus 48 squared is equal to c squared. So 14 squared was 196. 48 squared is 2304. And that's equal to my c squared. So when I add those two together, I get 2500. And that's equal to c squared. So again, we're going to take our square root of both sides. So 50 is what is equal to c. So notice that all three of these numbers are whole numbers, right? So yes, this is a Pythagorean triple. And our third side was 50, okay? All right, so here we go again. Notice that this is the opposite of the right angle. So this is going to be our c, right? I'm just going to make this side my a and this side my b this time. So once again, we're going to say a squared plus 4 squared is equal to 12 squared, okay? So that's going to be a squared plus 16 is equal to 144. Subtract the 16 from both sides, so that's a squared is equal to 128. Now, if you were to just take the square root of this in your calculator, you're going to see that you're going to get a decimal, okay? So it's not a Pythagorean triple, so that's no, okay? But now we still need to simplify this, okay? So what we're going to do is go ahead and take the square root of both sides here. And notice that that's an even number because it ends in an 8, right? So we're going to divide this by 2, which is going to give us 64 here. Look at that. I realize already that's the square root of 2, and that's the square root of 64. We know what the square root of 64 is, right? So we're going to put it 8 radical 2. Always put your whole number in the front, okay? And the radical second. So that is our simplified answer. And here's the key, guys. If there's a radical or a decimal in the answer, then it cannot be a Pythagorean triple, okay? So I want you guys to do this, and I would suggest that you label the hypotenuse of all of these first and then work the problem. Okay? So go ahead and work them. Come back to me when you're done. All right, so this next one I'm going to label the C. So I'm going to say this is going to be my A, this is going to be my B. So 8 squared plus 10 squared is equal to C squared. That's 64 plus 100 is equal to C squared. That's 164 is equal to C squared. Take the square root again of both sides. Okay. So that's going to give me, now let's see. Can you guys see that that's divisible by 2? And that gives me 82. Well, 82 is still divisible by 2, right? That gives me 41, okay? So now here's the thing. If you guys see a number repeated, you know that's going to be a perfect square because 2 times 2 is what? 4, right? So this is going to be the square root of 4 times the square root of 41. And 41 is a prime number. Some of y'all may have known that. Some of you may not have. But we can't simplify 41 with anything else. So we're going to take that square root of 4, which is 2, and the square root of 41. And so that's our answer. And I said earlier that if there's a radical left in the answer, then the answer is no. It cannot be a Pythagorean triple, right? Okay, so here's our next one. So once again, we're going to label our C first. C is equal to that 26. I'm going to make this our A. This time this our B, okay? So we're going to do 24 squared plus B squared is equal to 26 squared. Okay, so this is going to be 576 plus our B squared is equal to 676. Subtract the 576 from both sides, so we get B squared is equal to 100, and hopefully all of you know what that is. The square root of 100 is 10, right? So B is equal to 10. So this time, notice we had what? 3 whole numbers. So this one is, yes, a Pythagorean triple. Okay, this next one down here says, again, find it. So I notice immediately there's a decimal there, right? So this answer is no for sure because it's not a whole number. But we're still going to do our A, B, and C. So this is going to be my A. This is going to be my B, and notice this is my C again because it's opposite the right angle. So we're going to do 1 squared plus 2.4 squared is equal to C squared, okay? So obviously 1 squared is 1 plus 5.76 is 2.4 squared. And so that's going to be equal to C squared. So this is going to be 6.76 is equal to C squared. So this time we're just going to take square root of both sides. And the reason why I know I don't have to simplify this one is because it started out with a decimal, okay? So the answer on this one is 2.6 is equal to C, okay? All right, let's see if you guys can do this last one. Noticing again that that is C, right? Because it's opposite the right angle. I'm going to say this one's equal to A, this one's equal to B. So it's going to be 30 squared plus 16 squared is equal to C squared. That's 900 plus 256 equals C squared. That's 1156 equals C squared. Take the square root of both sides again. Right? So that's going to be 34 is equal to C. So if 34 is C, notice they're all whole numbers, right? So this is again a yes. All right, so our last concepts here is that we can follow the theorem to classify triangles as acute, obtuse, or right. So obviously when we do A squared plus B squared, it equals C squared, right? That's when it's a right triangle, okay? However, if we compare C squared to A squared plus B squared, look over here. If we compare C squared and it's greater than A squared plus B squared, then it's going to be an obtuse triangle, okay? If we compare C squared to A squared plus B squared, and it's less than, then this is going to be an acute triangle, okay? Now here's the other thing, and this is where I would start with all of these, is determine if we can even make a triangle, okay, with the 3 sides, okay? So if we can make a triangle, then what we're going to do is add 2 sides together and see if the third side is greater, or if the 2 sides added together are greater than the third. Okay, so let me just show you how this works, okay? So I'm going to do it. You guys will understand it better when I show you. So on this one, we're going to say, we're going to add 5 plus 7. That's 12, right? So we're asking ourselves, is 12 greater than 10? Yes. So because 12 is greater than 10, this is a triangle. So we're going to say yes, because it asks us, tell if the measures can be the side lengths of a triangle, and then we're going to classify. Okay, so on this one now, we're going to see which one. This is our C. How do we know that? Because it's our biggest side. So we're going to go 10 squared, and then we're asking ourselves, how does it relate to 5 squared plus 7 squared, right? So this is going to be 100, and this is going to be 25 plus 49. That's 74 and 100, okay? So what is the relationship there? Obviously, c squared is greater, right? So this is greater. So that means this is an obtuse triangle, okay? Got it? Now on this next one, we're going to add these two numbers together, the smaller two numbers, 5 plus 8. That's 13. Is 13 greater than 17? Absolutely not, right? So this is not a triangle, okay? If I add those two smaller sides together, they have to be greater than the third side for this to even be able to be a triangle, okay? So let's go ahead and do these three you tries at the bottom and come back to me when you're done. So here we go again. We're going to add the 7 and the 12. 7 plus 12 is 19. Is 19 greater than 16? Yes. So we can form a triangle with them, right? So now we're going to take that 16 squared, and we're going to ask ourselves, how does that relate, okay? 16 squared, how does it relate to 7 squared plus 12 squared, right? So that's 256. This is 49 plus 144. So 256. We add those two together, 256. How does it relate to 193? It's greater, right, y'all? So it's a greater here. So if it's greater, again, what do we know? This is another obtuse triangle, right? Okay? All right, so let's do this next one. Add those two numbers together. 11 plus 18, that's 29, right? How does 29 relate to, is 29 greater than 34? Oh, no. It is not. So this is not a triangle. And here's the deal. If it's not a triangle, then we obviously don't have to determine whether it's acute or obtuse, right? Or right. All right, so here we go again. We're going to add these two together. 3.8 plus 4.1, that's equal to 7.9. Is 7.9 greater than 5.2? Yes, indeed. True statement, right? So we can form a triangle, so say yes. And then we're going to figure out whether it's acute or obtuse, okay? So we're going to take our c, which is our bigger number, right? We're going to do 5.2 squared. And when we do 5.2 squared, we get 27.04, okay? And then we're going to compare that with, right, question mark, right? We're going to compare that with our 3.8 squared plus our 4.1 squared. So when I add those two together, I got 31.25. So this time what is true of our hypotenuse? It is less than, right? So this is going to actually be an acute triangle, okay?